Welcome back to Tea and Code. In this video we're going to be writing a solution for cheapest flights in K stops. Let's have a look at the description. There are n cities connected by some number of flights. You're given an array of flights where flights at I from I to this index, from here to here at some price or cost indicates that there is a flight from city from to city 2 with a cost price, is what I just mentioned there. So you are also given three integers: source, destination, and k. Return the cheapest price from source to destination with at most k stops. If there is no such route, return -1. So here, for example, from 0 we can go to this stop at cost of 100. From here we can go to 2 at a cost of 500. And destination is 2, so we can reach destination 2 at the cost of 500, or we can reach destination 2 at the cost of 200. So here the least cost to reach this stop is 200 with at most k stops. So number of stops here is 1, so we just had one stop here and we can reach it with just that one stop. Here as well, so this time the number of stops that we have available is 0, so we can reach it here at a cost of 200, but that we don't have any stops to use, so we just go straight here, so that would be at a cost of 500, so we'll just write up here as 500. So for this we can use Dijkstra's algorithm, so we'll give that a go. So Dijkstra's algorithm effectively so what we'll do is we'll create a adjacency matrix, so that we and then from there we can create heap sort to select the current cheapest node from the node that we're at, the current node, and then from there we can go from there. So whichever node is cheapest is the one we'll try first, and then from there we'll check from that node which is the cheapest path to the destination. So it's basically what happened here. However, also the other condition we have is we need the cheapest cost, so I mean the least amount of stops, so at most k stops. So even if we have the cheapest path, we still need at most k stops, so we'll need to consider another path. So sorry, what I didn't mean was that the least amount of stops, but we need to consider that the amount of stops, k amount of stops. So that with Dijkstra we'll pick this. We'll always pick this path as the cheapest path. But because we don't have any stops in this case, we'll have to go with this path instead. So this part needs to be considered for this solution. So Dijkstra's So first we'll build an adjacency matrix. Adjacency matrix. So for each flight in flights, we'll give the nodes just will the matrix will be full of edges. So from a city to another city. So flights. So now we're also going to create a shortest distance array to keep track of the shortest distances for our min heap function. So here we want to keep track of the number of stops as well. So at least I'll keep track of stops destination. So here we're just initializing the arrays. And now we're going to, so we can write a function for minimum heap to pick the node with the shortest distance, but instead we'll use a priority queue. So priority queue now so main part of the solution. Yeah. So heap is MC. So this is going to be the next node, and this is going to be the cost for the edge, and this is going to be the current number of stops to this particular node. So if we reach the destination, we'll just return the cost. So if return cost destination is reached. And here we want to return, we're going to continue if we run out of case stops. So we'll try another node. So if we run out of stops, continue to another node. So that's that. So so here, so I'm going to check if this if this node exists. If it does exist, there's a node in this here. Then we're going to want to get to the distance from the root. So we want to get the costs at the root, and then we want to get the distance from the root to where we are. So so here we'll just add the current cost from this that we're looking at now. So that's that. So here we're going to update the cost if the distance to this node is less, to the root is less than what we have this as a distance already. So we'll update that, and we'll add it to the queue. So first, so update costs. D and B. So that's the case. Min heap offer also want to update the number of stops as well. Or rather, if the number of stops is less, if the distance is less, we can update the number of stops instead. So we can update the number of stops instead and get the yeah. So at least if we can update the distance, we can still update the number of stops. So it's minimum minus as much as possible. Stops. Just copy this from here. Alright. So now stops. Just update that here. So now we've reached this. Now we'll just update the number of stops. So that's that. Very good. So finally, the last thing that we want to do is that we want to return, if we reach the destination, we want to return the cost. If not, we'll return -1 as it says here. So we'll check if the distance hasn't been, we haven't reached the distance yet. We have, so distance max value -1 or alright, so that's that. Pretty simple. Let's give that a go. Oh, compile error. Current stops. Again. Compile again. Let's go this again. Next time. Distance is so yeah, from the when we reach destination. So let's give this a run. So submit. Great. So there we go. 97.4%. Very good. So if any of you have any questions about this solution, leave in the comments below. Leave a like, subscribe. Thanks for watching.